In the previous examples, we assumed that the payments were made at the end of each month, but that's not always the case. Sometimes we make the payments at the beginning of each period instead. That's referred to in the literature as an annuity due instead of a standard annuity. So annuities due include things like insurance premiums and rents, where you have to make the payment at the very beginning of, for example with insurance, at the very beginning of the period for which you're covered. A lot of times it makes sense to think of savings the same way. So if you imagine that you don't start counting time until when you make your first payment, then you would think of that first payment as being made at the beginning of the first period. So the idea of an annuities due can be converted into a formula, and basically we only need to make a small adjustment to our previous formula. If the payments are accruing interest starting the beginning of the month, that means every payment gains interest for one additional month, which means every payment gets multiplied by an additional factor of 1 plus the periodic interest rate. So in order to take our old formula for the future value of an annuity and convert it into a formula for the future value of an annuity due, all we have to do is take our total and multiply it by an extra factor of 1 plus I. And that's what this formula is. You can see it looks identical to the future value of a standard annuity, but it's got an extra factor of 1 plus I. So let's use that an example. Let's find the future value of a series of payments made at the beginning of each month. In this case, beginning of each month for 5 years with a periodic interest rate of 0.3%. So we have a $200 payment size, 60 payments, that's 12 payments a year for 5 years. Our periodic rate, we're told the periodic interest rate, but it's 0.1%. So we have to be careful to convert that to a decimal appropriately. It's not just 0.03, it's 0.003. And we want to figure out the future value. So we plug our values in. 200 for PMT goes right here. 1 plus I shows up here and here. N is 60 payments, and I is again in the denominator. Plug that into a calculator carefully, and you end up with $13,165.70. Here's another example. We make a payment at the beginning of each month of $100 into a savings account that pays 2.4% annual interest, and we want to know how long it'll take for the balance to exceed $10,000. So we know the future value should be $10,000. The monthly payment size is 100. The periodic interest rate is the annual interest rate divided by 12. And we want to solve for the number of months that pass, the number of payments that we make. So we plug everything into our annuities due formula, and we're going to solve for n. So the first thing I will do is divide both sides by this number. So I canceled some zeros. When I divided by 100, I canceled a couple zeros, and that's what gave me 100 in the numerator. And then I'm dividing by 1.002. That's how this ended up in the denominator. The next thing I'm going to want to do is multiply both sides by 0.002. And if I do that on the left side, all I have to do is multiply the numerator by 0.002. 0.002 multiplied by 100 becomes just 0.2. Then I can add 1 to both sides. Now notice, when I add 1 to both sides, what I'm going to get is 1 plus 0.2 divided by 1.002. And if I want to combine those into a single fraction, what I can do is get a common denominator. So 1 can be written as 1.002 divided by 1.002. And then I'm going to add 0.2 over the same denominator. And to combine these fractions, now that they have the same denominator, all I need to do is add the numerators. And so that's where the expression on this screen comes from. I'm finally ready to isolate n using logarithms. So I'll take a logarithm of both sides and bring the exponent out front. And then I can isolate the exponent n if I divide both sides by log of 1.002. Type that all into a calculator carefully, and you get approximately 91, a little bit over 91. Now, if you go back to the original statement of the question, it asked, when will we exceed $10,000? If I round this to the closest whole number of months, 91, I've not quite reached $10,000. I'll be a little bit short of $10,000, just a little bit. And I won't exceed 10,000 until the end of the that month, until the start of the next month. So in order to do that, I need to actually round up to make sure that I'm exceeding $10,000. So I should really say that it'll take 92 months for the balance to exceed $10,000.